We're going to be going over the Java solution for Leetcode 200, number of islands. Given an m by x 2D binary grid, which represents a map of ones, land, and zeros, water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So to understand the problem, we'll basically be given a character matrix and it will be consisting of ones and zeros only. So our job is to figure out how many islands are there, where ones will represent land and zeros will represent water. So to make an island, it has to be surrounded in all four directions by water, and we can assume that the outside of the matrix is also water. So the hard part comes in when we have to consider that connected pieces of lands, that's considered one island. This isn't considered 9 separate islands, but since they're all connected in the four directions, they're only considered one, just like how you would do in real life. So that's why this outputs a 1. For this one, this has 4 connected right here, this has 1 connected here on its own, and then 2 right here. So in total, there are 3 islands. So in terms of what we're concerned with, we're only concerned with the 4 cardinal directions. So that's why this isn't considered one island. Even though this is connected diagonally, we're only considering top, left, down, and right. So this is one of the quintessential sort of breadth first search introductory problems. So what breadth first search means is that it's a way to search for all surrounding cells. So for example, if we search this one, we can recursively call the top, left, down, and right, and then check whether any of those 4 are valid. In our case, if we consider ones to be valid and zeros to not be valid, then we would ignore this and we would look at this one, and this one. And then we could do whatever operation we need to do. And basically this will recursively call its top, left, down, and right. And then this one will also call its top, left, down, and right. And this one will also call its top, left, down, and right. And then that way we can basically check for all the ones, and if we ever get a 0, we can just ignore it and we can do whatever operation we want. So I'll just write down the solution and I'll explain it later, as I think it's going to be easier if I do that. So first we're going to count the number of islands, so it's best to have some sort of variables to keep track of that. Next, I'm going to make a for loop that basically goes through and checks the whole grid. Okay, great. So now I'm going to check for if that cell is valid. And in our case, we want to only look at the pieces of land. So I'll say grid ij, if grid ij is equal to a 1, then number 1, we can increment our counter, since we know if it's a piece of land, no matter how much it's connected, we at least found one island. So we could increment our counter, and next we can perform our breadth first search method. So what that'll take in is our coordinates, so our I and j, and our grid. And then after that, we can just return our count. And simple as that, except now we have to actually make our method. So public void bfs, and this will take in int I, j, and the char grid. Okay, so first step whenever you do breadth first search is to do boundary checks. So boundary checks are there to, number 1, make sure it's a valid cell. And that means that it's a cell we care about. So in this case, if it's a 0, then we don't care about it. And also if it's outside of the array, because we don't want to check on basically this top half right here. If we had this cell and we called basically the left and the top of it, it'll be outside of the matrix. So that's why we're doing our boundary checks. So if I is less than 0, or I is great, or I is, if I is less than, so if I is less than 0, or j is less than 0, or I is greater than or equal to grid.length, or j is greater than or equal to grid of 0.length, or if grid of I and j is equal to 0, then we can just return. We basically won't do anything to it. So now if it passes this if statement, then we know it's a valid cell. So number 1, it exists, and also it is a 1. It is a piece of land. And the first thing we're going to do is basically turn it into water. We're going to turn that land into water, and I'll explain why. And after that, we'll recursively call our method, but now to the other 4 directions. So I plus 1, I minus 1, j plus 1, j minus 1. So even if one of these methods that we called, even if they resulted in an invalid cell, the basically boundary check will basically not do anything to it. It won't affect it that much. So the reason why we changed this to a 0 is because we want to basically eliminate all of the surrounding lands, because we only are going to increment this count by 1. If we didn't do this, then this would basically iterate to the next cell, and if that was also a piece of land, even though it's connected, it will still trigger this if statement and basically increment our counter. So what this will do is, for example, at first it'll reach this cell right here, and then it'll recursively call both the right and down, and then also left and up, but then those won't pass the boundary check. So then it's going to turn this into a 0, and it's going to check on these ones. So this is important because when we recursively call the left in this case, it won't think it's another piece of cell and basically call it back and forth, back and forth, back and forth. Turning this into a 0 will make it invalid because we've already checked it. We've already visited it and we don't want to visit it again, so that's why we'll just turn it into a 0. So that way we can just basically go around, go to all the connecting ones and then turn them into zeros. And basically after that, we're still gonna go through our grid to find any more ones. And we know if we find another one in that case, then it was a completely separate island that didn't get erased or turned into a 0 when we were performing our breadth first search. So that is basically the idea and intuition behind breadth first search in this problem. So let's see if it works. Okay, great. Now let's see, submit it. Okay, great. So that was Leetcode 200, number of islands.